Welcome to the R learning session. Today we're going to do some R learning and we have a problem at hand. Let's go over a problem. We're going to provide some simulations in R. We're going to follow an example lecture where we imagine a case where the following a uniform distribution between 0 and theta, and two researchers are trying to figure out the value of theta. Here we'll assume theta is 5. We're going to simulate different random samples from this distribution with a sample size of 100 observations each. These samples will be available to two researchers, and we are going to plot how theta is distributed for different estimators. There are two types of researchers in this world. Researcher A uses an estimator for theta. There A is the 2 times mean, where mean x corresponds to sample mean of sample size he receives from us. Researcher B uses estimated theta B, or 2 times median, where median x corresponds to median of the samples that he receives from us. We will provide you with R code that has some information missing in case you need help for this exercise. So let's remove all these codes from this because we need to write it later. And so the first question is that what would be the mean of this distribution of x mean? Think for a few seconds. What would be the mean? That's the question we have. The mean of this distribution for this we need to run the sample size, right? For this we need to run the simulations, and what we need to do is once we run the simulations, we have all the sample sizes, and then we'll apply the mean, and then we'll get the answer. Now let's get started then. So we have been told that theta is equal to 5 and experiment size is equal to the 1000. There is a number of samples, and under each sample we have around 100 observations. Now what we need to do is we need to create a random uniform sampling where we have the value from 0 to 5, and we'll create a sample size of experiment size times sample size. So we'll run a simulations here. That is, we'll get a matrix run if experiment size times sample size, and minimum equal to 0 and max equal to theta, and the matrix will have the number of rows as experiment size and number of columns will be sample size. And next step, we'll apply the mean to the simulations and get the result. So let's run this. The answer is 2.5. That's the answer for this. Now, next question we have is, what will be the variance of distribution of theta A? Theta A is 2 times the mean. Please enter numerical value of the variance. Now, we will answer that. So to do this, we need to understand what theta is. Theta A equal to 2 times the simulation. 2 times the mean we get after we apply on a simulation matrix, and it's going to be instead of a vector. Then what we do is we apply the variance on top of that, and this should give us a variance of theta A, which is 0.077. Now, finally, does the distribution of theta A approach a normal distribution when n goes to infinity? The answer is yes, because of central limit theorem, as n approaches infinity, we'll have the normal distribution. Yes, due to central limit theorem. So let me quickly summarize what we learned today. We learned about the R, and we use to do that. We try to solve few problems, such as what the mean of a distribution of x mean, and we try to find a variance, as well as we learn some theoretical concept about central limit theorem. So that's all for today. I will see you next learning session. Thank you so much. Have a nice day.